Hey, hi, hello guys. Welcome back to Code with Nani channel today. So today we're going to discuss about what is called by value, called by reference, and some basic problems regarding functions. So if you don't know what is function, so do check out my C++ DSA playlist. So you'll find extensive video regarding functions. What are the types of function? How do we implement it, and everything. So let's get started. So what is called by reference and called by value? So whenever you call a function, and you pass a parameter to that function, so whatever the values that is passed to that function, so it will be called by value itself. What does that mean? So only the duplicate values of that particular parameter will be passed to that function call, and if you change any changes that made in the inside that particular function, that doesn't affect the real values of that real values in the main function. When you call it by reference means when you pass that address of that particular variable or particular vector or any other data structure, when you pass the say, reference, then whatever the changes made in that function will affect the original values of that function. So I'll give an example, then you'll get to know about it. So so let's just have an function like int int sum of int a int b, something like this. And in the main function we have, let's take in the main function we have int a equal to 3, b equal to 2, and you call a function sum of a comma b c out ab, right? So we're just printing out the ab. So what I want to do is, suppose we make a is equal to a plus 4. What we are doing? We are incrementing a by 4. What we are doing? And we'll increment b with b plus 1. Return, yeah, something code that goes in this way. So whatever the values that we transfer to this function call is a3 and b2. What we are doing in the particular sum is we are incrementing a by 4 and b with 1. But when you print out a b, what will be the values that will be printed? It won't print 7 and 3, because it doesn't affect this original values of a and b, because whatever the values that been passed to this parameter, only the duplicate values that will be passed. So if you write c out b, then it will print 7 and 3, but it doesn't affect the original values. So that's where, if you want to change the original values, then we will call it by reference. So as far as now, it is just a call by value, only the duplicate will be, it will be goes to that function call, and only that changes doesn't affect the original value. Suppose if you want to change the original values, then we will do is we'll just put an ampersand symbol. Wait, what we need to do is, in the main function call int and a, int and b. What does this and represent? And represents address of the memory location of the variable, address location. So if you give this address, no, this is the address 1024, something like this. If you give this address to this function call, whenever the changes made on this specific address, it's gonna affect the variable also. That's why if you give the address to that particular function, whatever the changes made in this function will affect the original values also. So if you call by reference means address location. If you call the function by value, it doesn't affect. If you call it by address location, call by reference, then whatever the changes made in the function will affect the original values also. So that's the only thing difference between call by value and call by reference. Suppose if you want to make any changes in the original values, then we'll use this call by reference mostly. Otherwise, we'll just go by the call by value. So I'll just give you an implementation so that you'll get to know everything related to it. So I'm just using Sublime. So guys, if you doesn't have a Sublime on your local machine, so do watch my C++ DSA playlist where I explained everything how do you install this Sublime on your local machine. So do follow the video and install on your local machine. So I'm just running on my Sublime itself. Suppose if you don't want to run in a Sublime text editor, just go to the online compiler and you can run over there. So so let's check. So I'll give you an example. Suppose int a comma b cn. I'm just taking the inputs and the cn and b. So yeah. What I'm doing is just create a void function, call it as change, which requires arguments as parameters as int a b. What I'm doing is I'm incrementing a is equal to a plus 5. I'm just incrementing 5, and b is equal to b plus 3. So let's see whether the values will be changed or not. So I'm just calling the change function, and whatever the parameters that I was passing is a comma b, right? Just run it. So as far I said, this call function will only call by value. So whatever the changes made in that particular function, it doesn't affect the original value. So the default values which I have been given input, it will be printed, right? Delete every test cases that I have run before. So what I'm just giving is I'm giving input as 3. I'm just giving input as 3, 4. So what will be the just guess the output. So what will the values that will be printed? It will just print the 3 and 4 because there will be no changes in the original value. See, 3 and 4 is printed. Suppose if I pass it as a reference, which means I'm just passing the address location. So whatever the changes that made in that particular address location will affect the values. So just save it and run it again. See, 8 and 7. So 3, and we are incrementing with 5, and 4, we are incrementing with 3. So 8 and 7. So that's the difference between call by reference and call by value. Now let's get into this problems. Let's get into the problems based on the functions. Suppose, suppose, suppose we have inputs called. Suppose we have input intervals start and end. Let's say start will be 1 and end will be something like 100. So what we want to do is, what our function need to do is, we need to print all the prime numbers that are between start and end intervals. So we need to print the start and end intervals, which is equal to 1, 100. We need to print all the prime numbers that are lies between 1 and 100. So how do we going to do it? So as we all know, we have already discussed about how do we check out whether a number is a prime number or not. So if you doesn't know what is how do we check the prime number, go check it out on my playlist, and you'll find a interview problems playlist one, I guess, interview playlist one. So do check it out, and I'll explain very clearly how do we check prime number, what is a prime number. So do check it out and come back again here, so you'll get to know how do we check how many numbers that are between start and end intervals. So what we do is for we loop from end I is equal to start interval, and I less than or equal to the end interval, and you'll iterate. What we're gonna do is we'll create a prime function, right? Is prime function. So that's gonna do the task for us. Checks whether number is prime or not. So for that specific I, if it is a bool function, which means it will return the true or false. So if is prime of I, which means we are calling the is prime function with a specific I. which means we are starting from 1, right? So for first input will be 1. So is prime of 1, like it will call the is prime function, is prime, and the input is then n is equal to 1, because 1 will be allocated, and it will check whether this number is a prime or not. If it is a prime, it will return true. If it returns true now, then what will does is, if if statement will does, it will execute the whatever the statement that I kept right inside. If it returns false, if returns false, then if statement doesn't works. So that's how we look from start to n interval, and we check whether each number is a prime or not. So what we do is we'll create a separate function is prime, and we'll write whether that particular number is prime or not. If that is a prime, then we'll write prime. So let's just code it. You'll get to know about it. So what I'm doing is just take two intervals and start, right, and start comma in. I'll just take the two intervals, start in, and what I'll do is I'll just loop from 1 to, sorry, from start to less than or equal to n I plus plus. What I'm doing is if is prime, I'll just make is prime, and it'll pass a parameter as I. If that is true, so if that is true, let's say that is true, what I'm doing, see out I, because what we are doing, we are checking the numbers which are prime numbers from start to n interval. We're gonna print that particular number. So that is it. And after that, the numbers. Let's make. Okay. So just write the is prime. So we are returning true or false, right? So then what will be the data type of the particular function? It will be a bool. Boolean means either it's a true or false. Bool means 0 or 1. 0 represents false, 1 represents true. So whenever there is a two binary numbers, we're going to take it as a Boolean expression, whether it is true or false. That's why bool. And the name of the function is prime. What is the input that is taking? Parameter. It's just a number. So even I pass I, so this is the main example. What I say in the call by value reference, call by value means it will just pass the values into that particular function, just duplicate values. That's right. So even I write is prime of I, right? And in the function what I'm taking is prime of int n, right? So even the variable names are different, still it works. How it works, it will just pass the value of I, duplicate value of I to this particular function. If the value is 5, it will just pass the 5 to this function. That's it. It doesn't do anything regarding whether it is a matchable variable or it is not matched. It will just check, it will just what is do call by value, just pass the duplicate values to that particular function. So even if you write a different name, still it works. So I'm just taking the int value. Just data type has to be the same. Okay. So I'm just passing the value. So we will write the same function which we wrote in the loops concept. How do we check whether a particular number is prime or not? So what we do, we just make flag to check whether it is a particular number is prime or not. Whether any number is divisible by a particular number or not. So So what we're gonna do is, if base case, if n is equal to 1, return false. So why we are writing? Because to check whether a number is prime or not, we will look from 2 to less than that n number, less 2 to n minus 1th number. If n is 1, it is not a prime number. So we will just return it as a false. Otherwise, we'll take the flag as 1 and we'll look from 2 to less than 2 to a particular number. If n any number is divisible by 2, then what we'll do is we'll make flag equal to 0 and break the loop, right? So in the end, what I'm doing is return flag equal to 1. So remember, do you remember the control statements? What I'm doing, ternary operator. If flag equal to 1, which means if flag is 1, if it is true, whatever the thing that I wrote after the question mark will be executed. Otherwise, it will. Otherwise, the colon of whatever I write after the colon, that will be executed. Flag is 1. What we need to do? It is true. It is a prime number, or else or else it is not a prime number. So we'll return this false. So that's how we just run the program. Give two inputs. Let's say 1 and 100. So it will generate whatever the prime numbers. See. You got the 25 prime numbers that are lies between 1 and 100. Can you give other numbers? Suppose 100 to 200. Give them whatever the prime numbers that are between 100 and 200. So that's how this prime number works. And coming to our other question. So, so we have completed call by value, call by reference, and we know primes in between interval. So the same way. So suppose if there is a start and an interval, and if you want to determine how many Armstrong numbers that are between from start interval to in any interval, so I'll do the same thing. I'll explain this also. So what we're gonna do is we'll just iterate from start to end if same way in this way also. If is Armstrong, if it is an Armstrong of 5, we'll just print see out. Hey, which means that particular number is an Armstrong number. Hey, yeah, it's not. Isn't it? So what is Armstrong number? Armstrong number is suppose we have a 153. Even 1 cube plus 5 cube plus 3 cube is still be equal to 153. So that is an Armstrong number. Suppose if the length is 4, what we had to do? 1 power 4 plus 5 power 4 is the power 4 plus 4 power 4. If this value is equal to particular value of then it is an Armstrong number, right? If number of digits is 4, then we have to power it by 4. It is 4. So 1 power 4, 5 power 4, 3 power 4. If still the value will be equal to the particular number n, then it is Armstrong number. So we have to check for the particular start and end interval how many Armstrong numbers are present, or just print the Armstrong number. So just loop from start to end and you check for particular number is an Armstrong number or not. So we already discussed how what is an Armstrong number and how do we implement whether the number is Armstrong number or not in our previous loop concepts and loop problems. So I'll just do the same thing. So how do we write? So we'll just do what we need to do is if is the same way, just same way, start end, and you'll do from start to end. If is Armstrong of I, so Armstrong of I equal to true, then what we're gonna do is just see out that particular I. So how do we write? Let's make boo is Armstrong. Whatever the value that is being imported is n. So then while let's just take for the value int result is equal to 0, comma ans is equal to n. So why we are storing in the ans? Because if you go through the slope, then n becomes 0. Then how do we compare the value result with the nth value? So that's why we are storing this in ans and we are comparing it then. So to iterate, we are use answer greater than 0. So guys, if you want extensive video on this Amstrong number, do check out my previous video in my DSA playlist. So you'll find a extensive explanation on how do we implement and everything. Right now, I'm just going in a pace so that I can cover more examples. So if you need from scratch, just do check out my previous videos and just come again here. So if answer is greater than 0, just take this last digit as and percentage 10. And what we need to do? RT plus is equal to, right? RT plus RT equal to result, previous result, plus power of that last digit, comma int count. What is this count? I'll explain you what is this count. Count n is equal to 1 bit. And so I'm just using if, no, ans is equal to ans because I'm looking through ans. Okay. Okay. So return if result equal to the value of n, we just return true, or else we just return false. So what is this count? What is this count? So in our previous example, what I told you, if we have the example 1 5 5 3 5 4. So how many digits? 1, 2, 3, 4, 5. So n is equal to count is equal to 5. That's why what we are doing. So it's just 1 5 3 4 5 4. Whatever the last digit will extract from this number, 4 power 5. What is this 5? Count of the number of digits. 4 power 5 plus 5 power 5, 3 power 5. So plus 5 power 5 plus 1 power 5. So I have to power these numbers with the number of count of the digits. So that's why we are making a count variable and passing to this function, right? So how do we get this count? So instead of just passing to this count, what we can do is let's delete this, and to get this count, int count is equal to, just write the function for the count. Just pass the n value to it. So how do we count the number of digits? So we'll just return the int value count. What is the number that is passing to this n? So how do we count? Why count equals 0 while the particular number is greater than 0. Count plus plus will increment the counter and will decrease the digit by 10. So same way as how do we reverse the number or check for the palindrome, we'll extract the last digit and will clear that last digit. How do we clear this last digit? We'll divide by 10, so that last digit will be erased. Suppose we have a 3 3 3 3 4 5, something like this. So how do we count the digit in reversing number? We'll just extract this last digit, and if you divide this by 10, what the number becomes? This 0.5, as int can only store the integer result, so these results become 334, right? So in this way, if we divide n by 10, so the last digit will be eradicated. So how our algorithm works? While n greater than 0. Suppose take 34 ct plus plus n equal to n by 10, right? So 34 comes as 34 greater than 0. Ct becomes now 1. Before it was 0. Now ct plus plus ct becomes 1. And n becomes n by 10, which means 34 by 10 is 3.4, that is equal to 3. Because it only stores the integer value. As in other iteration, n is still be greater than 0. Now the ct becomes 2. And n becomes 3 by 10, which is 0.3. Now value becomes 0, and check for the condition n is not greater than 0, then loop will come up, then this loop will be terminated and we'll just return the count. What is the return of the count? 2, because this is 2 digit number. So that's how our algorithm works. So I'll just doing the same thing and just returning the count. So that count will be checked. That count will be powered. Pivot function, POW function is a power function, which takes. So it is it is in the mac.h library. So if you include bits.h library, which are standard C++ H file, it will automatically be included in the math H file. So what does it do? Power function does is power of 2 comma 3, which means it is equivalent to 2q. So which is, this is the base and this is the exponent. So if it is power of 5 comma 2, base is 5, power is 2, 5 square 25. So that's how power function works. So that's what we do here. So power of base will be the LD and CT will be the power. If it is 2, that's how. So I'll just run it. So so just include bits library standard C++.h. So if you include this header file, it will include every other header files. So can directly just give this, still compiling. Just delete all other previous responses. So what I'm going to do is I'll give start interval as 100 and end interval as 1000. It will give all the Amstrong number that are between these two intervals. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Because you can make a single digit if it is number example 6. So even if you power 6 power 1, still it will be the same as the previous. That's why all the single digit number are Amstrong numbers and 153, 370, and there are some other few other Amstrong numbers. So that's it for it today's video, guys. So we learned everything related to functions. So how do we implement functions, function on function? So we implemented inside a function, inside other function. So we have learned, and we also solved some standard problems regarding functions. So these are the standard problems for the interviews as well regarding related to the function. So that's it for today's video, guys. So see you tomorrow. If you like the video, do share to subscribe to my channel, share it with your friends, and like the video. So that is for today, guys. See you tomorrow with a new content. Bye bye.